Hello, everyone. Sorry I couldn't be with you today, but I have to take care of some funeral arrangements today. So what I'm going to do is I'm going to cover around 8 or 10 proofs of 5.1. Now, I will tell you, you can watch me all day long, and until you try this yourself, you're going to look at my steps. You're going to say, okay, that makes sense. That makes sense, and everything else. But it's different than not doing it for yourself. Okay, it's easy to follow somebody doing a proof, but it's harder to know what those steps are. So I will warn you, this is going to be probably one of the most complicated things you do this semester. And in that regard, I'll cover some more on Thursday when I'm back in the class. But the good thing about this, though, is in class, when I go over them, if you don't remember my steps, or if you didn't write something down, or you couldn't keep up with me, then you've lost it. But this time you can look at my videos over and over again. So that's the good thing about it. So, but anyway, I'm just giving you a little bit of forewarning that this stuff is not the most easiest thing you'll ever see. Okay. So what I'm going to do is I'm going to share my screen. Actually, I'm going to share my screen here. And then I'm going to bring this over. All righty. So here is some. If you notice, there are 60 of these things. You're only seeing 22 of them. I'll probably do about 3 or 4 of them on this page. I'll do some on the next page. I'll make some more copies of there. I'm just telling you, though, it's not, just be forewarned. You're like, well, how do you prove an identity? Well, we did go over this a little bit last time in class. And I told you, well, you got 2 sides of the equation. You can make the left side equals to the right side by a series of steps. Every step is either algebraic or trig identities that you've already seen before. Okay, so that's one way of doing it. Another way of doing it is doing the same thing, but make the right side equals the left side. And best way to do it, though, is if you look at, like, for example, number 14, you probably don't want to make the right side look like the left side on number 14, because the right side's already been simplified version. And that's usually what it is on these proofs you'll see here. The left side would be more complicated than the right side. So typically you want to make the left side equal to the right side. Although it is, you can make the right side equals to the left side. It's just most of the time it's more complicated. And then another way to do it, it's legal, but it's probably not the best form. And that is work with the left side until you can't work any further. Work with the right side until you get a step that's equal to one of the steps that you had on the left side. And that's kind of, I call it weak. And so it's not the best way to do things, but some people choose to do it that way. Okay. All right. So what I'm going to do is, I think we did one of these earlier ones last time. So what I'm going to do is I'm going to start with number 9. Okay. So we look at number 9, and I'm going to put it up here. All righty. Number 9, and it is, we were going to prove that the cosine squared of x minus the sine squared of x is equals to 1 minus 2 times the sine squared of x. Now, so remember, we have the fundamental identities that we can use. One of those identities, I see a lot of sine squares and cosine squared, is note that sine squared of x plus cosine squared of x equals 1. Now, this is one of my fundamental identities. Now, typically, when you're trying to prove one identity is equal to the other side, the left side is equal to the right side, you can't bring one side, something from the left side to the right side, except if you already know it's true. And this one we know is true because we've already proved it, and it's one of the fundamental identities. Now, if you look at this thing, look at the left side, cosine squared minus sine squared. The right side has all sine squares. That's all it has. So what I'm going to do is I'm going to take this cosine squared right here, and that is equals to 1 take away sine squared of x. So these are kind of equal. I mean, they're basically saying the same thing. These things here are equal. So sine squared of x plus cosine squared of x equals 1 is the same thing as cosine squared equals 1 minus the sine squared of x. So what I'm going to do is I'm going to come over this identity that I'm trying to prove, and I'm going to substitute that in for cosine squared, because what is cosine squared? It is 1 minus the sine squared of x. That's what cosine squared is. And then bring this one down. Now, that's the trig. Now the algebra. What is a negative sine squared and a negative sine squared? That's a negative 2 sine squared. And that, if you look and you keep peeking to the right side, that is exactly what the right-hand side now is. So it's just 2 steps to do this problem. That's it. Now, this one's an easy one. So don't expect them all to be that easy. But you have to know that this is the same. Now, another one that would be equal to that would be saying sine squared of x is equals to 1 minus the cosine squared of x. That one would not have helped us in this case, because if you'd have got this sine squared right here and changed it to 1 minus cosine squared, then you have the left side all with cosine squares and not sine squares. Okay, so that's number 9. Okay, now, as a matter of fact, I think you probably want to use that second one on number 10. Because if you look at the left side on this one's cosine squared minus sine squared, the right side is 2 cosine, so there's no sine squared. So you probably want to use that second one on number 10 there. Okay, so now let's look at number 13. All right, 13 is tangent of theta, okay, times the cotangent of theta all over cosecant of theta is equals to the sine of theta. So then you look at this, and it looks really, really scary, and it can be if you don't know some of the basic identities. Sine squared plus cosine squared equals 1. That's something you got to know. But you also got to know the reciprocal ones. In other words, that tangent of theta is 1 over the cotangent of theta. Also, you could also say cotangent of theta is 1 over the tangent. That's the reciprocal. That's a pair of the reciprocal identities. Another one is that the cosecant of theta is equals to 1 over the sine of theta. Another thing is saying that the sine of theta is the same thing as 1 over the cosecant of theta. So these are the reciprocal ones. And there's other ones. There's the secant and the cosine. So that's the other pair. But I don't need to use that one this time. So if you look at this, I'm going to use this one first. So tangent of theta times 1 over the tangent of theta over the cosecant of theta. Then that tangent and 1 over tangent, there, if you multiply those together, it's tangent divided by tangent, which is 1. So it's 1 over the cosecant of theta. Because when you multiply reciprocals, that's just 1. So this is just that 1 right there. And then 1 over cosecant is using this one. And 1 over cosecant is the same thing as the sine of theta. And lo and behold, that is the right side. So that's number 13. Okay, so I mean, you're like, well, that's pretty easy. But it's the thing is, guys, is when you're seeing this, if you don't see that connection that the tangent is 1 over cotangent and cotangent is 1 over, if you don't see that connection, then it becomes really, really hard. You know, is this the only way to do it? No. I could change all these tangents to sines and cosines automatically. It's just going to take me a few more steps. So, but it's doable that way as well. So if you're reading it, if you go along with me in the book, the books will say convert. One of the first steps is to convert everything to sines and cosines, and that can mislead you sometimes. Sometimes it's easy if you don't do that, but sometimes it is. What my suggestion would be is, if you don't know what to do with it, then do that. If you don't see that the cotangent is 1 over tangent, and that you can just cancel these out to 1. If you don't see that, then maybe you should go to convert tangent to sine over cosine and cotangent to cosine over sine. But that's up to you. So, all righty. So that's 13. Okay, let's look at another one. Okay, let's look at number 17. Okay, so sine of t times the tangent of t is equals to 1 minus the cosine squared of t over the cosine of t. And you know, sometimes I'll do this problem and I'll go to my next class because you got 2 straight classes right back to back. A lot of the times I will go to one class and prove it one way, then I'll go to my other class and prove it another way. It's just kind of how I'm feeling at the time, I guess. It's just there's so many different ways to do them, and which is why some people don't like proofs at all, because they want one way and only one way to do the problem. And if you're that kind of a person, and some people are, you won't like these too much because you're second guessing yourself. So I like the freedom. Personally, I like the freedom knowing that if I see a problem and if I can't do it one way, maybe I can figure it out another way. So, but anyway, it's pretty easy. This one's a pretty easy problem. Make the left side. See, if you notice, guys, every time I'm working with the left side down, working with the left side solely, just working that left side until I get that right side. So my goal here is to make the left side equals over here. Now, the first thing I want to notice is that the tangent of t is the same thing as the sine of t divided by the cosine of t. And if you multiply those out, that's going to be sine squared of t over cosine of t, because that's algebra, because sine of t over 1 times sine of t times cosine of t, multiply the numerators, sine squared, multiply the denominators, cosine. And if you recall, I have the bottom, what I want. See, the bottom is cosine. That's cosine. That's good. It's the same thing. So the top here is sine squared, but the top up here is 1 minus cosine squared here. Are those the same thing? And it is, because where'd I put it at? Right there. Because sine squared is right here. It's the same thing as 1 minus the cosine squared. And that, my friends, tells me I'm done. So I just changed sine squared to 1 minus cosine squared, and that is the right-hand side. Okay, so that's number 17. So, you know, it's doable. Okay, it's doable. All righty. All right, let's look at one more of these and we'll go to the next page, number 21. Okay, we got tangent squared of t over the secant of t equals secant of t minus the cosine of t. Now, let me tell you what some people will want to do here, okay, and it's not legal. They want to see that the left-hand side's got a denominator. It's got that secant of t, right? And so what they'll do is they'll multiply the secant to the right side, and you can't do that. And you're like, why not? Well, because in order for you to multiply the secant to the other side, you have to assume that they're equal, and we don't know they're equal or not. So you can't move this secant on the denominator to the right side, even though it's tempting. Matter of fact, if you did, it would be very easy to do. The problem would be, but you can't do it. So what do I do? Well, I look at the two things here, like secant squared, right? I do know that 1 plus the tangent squared of t is equals to the secant squared of t. I know that. So I'm trying to find a connection between the tangent and the secant. So therefore, I know that the tangent squared, that would be the same thing as secant squared of t minus 1. Okay, so that's what I'm going to do. I'm going to take that, be secant squared of t minus 1 all over the secant of t. Now, you're like, why did you do that? Well, because this has 2 terms. Right now, this only had 1 term. I need to make this 1 term into 2 terms. And that's the way I can do it. So then I can break it up, secant squared of t over the secant of t minus 1 over the secant of t. And then secant squared over secant, of course, is secant. It's like saying x squared divided by x. And then 1 over secant, remember, is a reciprocal And that was the third one of my identities. That, you remember that if you had secant of t, that's 1 over the cosine of t. And cosine of t is 1 over the secant of t. That's the third of the reciprocal ones I didn't write down a while ago. So 1 over secant is cosine. And that, my friends, is what I needed. Okay. So, I mean, it's a process. It is a process. Okay. So it's not the most easiest thing you're going to see. And I'm going to just let you guys know the ones that you are doing, are going to be different than these possibly. So I just want you to understand that. All righty. So I'm going to take this away. Now what I'm going to do is get some more of these. My snippet's a little different on my computer at home than my office one. I had to find it. Okay. I'm going to go down here to about 44, I guess. There we go. Okay, so it should still be able to see that. So, I mean, if you notice, there is a bunch of them. There's a bunch. Now, 23 is pretty easy. I'm not to even do this one, but I'll do it anyway. So 23, 1 minus the cosine of t over the sine of t. We want to prove that is equals to, actually, they're using thetas. I'll stick with my t's. Cosecant of t minus the cotangent of t. As long as the argument is the same, you can use thetas or t's typically. So you don't want to mix and match them. So this is pretty easy though, because the left side, I'm just going to break it up into 2 fractions. 1 over the sine of t minus the cosine of t divided by the sine of t. Okay, and 1 over sine, remember, is cosecant, and that's the first term on the right side. And here it is. You're like, well, I don't know what this is. Well, kind of guess. So I mean, think about it. Here's cosecant, here's cosecant. And that's, like I just said, don't mix and match them. So cosecant of t, cosine over sine, well, it's cosecant minus. Well, that is cotangent. And that is the right-hand side. It's a minus there. So not too hard, not too hard, okay? Now, they get a little bit more complicated. If you look at number 29, okay, 1 minus the sine squared of x all over 1 plus the cosine of x equals the cosine of x. You know, it's very easy and it's very tempting. It's very tempting when you're seeing these problems. Is like, what's the point of this? You know, well, like I've told you guys in class the other day, I mean, it's like, if you're trying to manipulate something, you want to work with the most simplified form of that thing. So in other words, in calculus, you might be given 1 minus the sine squared. You might be given the left-hand side, okay? And you may have to do something with it, maybe taking the derivative or something else, and the antiderivative or something else with that. Well, it would be good to know that that is the same thing as the cosine of x. So we're learning that manipulation of how to convert one form of a trig function or a trig expression into another form. That's what we're learning. So when you're proving identities, you're learning to manipulate a trig expression to a different form. Maybe it's easier to work with, okay? So you're like, well, how you do this part? Well, that's pretty simple. First of all, I don't like the sine squared because the right side has cosine, everything else has cosine. So what I'm going to do is I'm going to change that sine squared to 1 minus the cosine squared. Remember, that's one of the trig identities. Now, the left-hand side, the numerator is a difference of squares. 1 minus cosine squared is 1 plus cosine of x times 1 minus the cosine of x. And the denominator is 1 plus cosine of x. And so those cancel. So you have 1 minus cosine of x. Now distribute the negative, okay? So it's going to be 1 minus 1 plus cosine of x. Like, why is it plus now? Well, because the minus has got to distribute through the parentheses. And the ones now cancel, leaving me with the cosine of x. But I want you to notice the number of steps have just increased. Everything I've done up to this point is 2, maybe 3 steps. This one took me 1, 2, 3, 4, 5 steps. Don't be surprised if it takes you 7, 8, sometimes 9 or 10 steps. So don't be surprised if that happens. Okay. Now look at number 33. I always thought this one's kind of surprising because when I first saw it, I said, no way that can be the same thing, but they are. Secant squared of x times the cosecant squared of x is equals to the secant squared of x plus the cosecant squared of x. Okay. When I first saw that, I was like, there's no way that a product of 2 trig functions can be the same as their sum, but it is in this particular case. Secant squared times cosecant squared is equals to secant squared of x plus cosecant squared of x. Now the trick is, how do you prove that? Okay, well, we do know that the secant squared is the same thing as 1 plus tangent squared. And we know the cosecant squared is going to be 1 plus cotangent squared. So this one's going to be 1 plus the tangent squared of x. And this one here is 1 plus the cotangent squared of x. That's the other form of the Pythagorean identities. Now you FOIL that one out. 1 times 1 is 1. 1 times cotangent squared is cotangent squared of x, okay? And then tangent squared times 1 is tangent squared times x. And then tangent squared times cotangent squared, well, just multiply those together, and that's going to be plus tangent squared of x plus, times the cotangent squared of x. Okay? Now, thing about this now is if you look at that, the tangent squared and cotangent squared are reciprocals. So this is going to be 1. And 1 plus 1 is 2. Okay? But you look at that and you're like, well, wait a minute, there's no way that's going to be equal. So what do I do? Well, let's see, we got 2. Cotangent squared is going to be what? 1 over tangent square of x, okay? And then that one here, maybe I shouldn't do it that way. Maybe I want to look at this another one. I just saw something else. Oh, go away, go away. I think I want to do this another way if I can get this thing to go away. Okay, whatever. I'm going to do it this way. I'm going to change cotangent squared to cosine squared of x over sine squared of x, okay? And then make this one plus the sine squared of x over cosine squared of x, okay? Now, what do I do now? Well, let's see. Let's see if we can put these all in the same grouping. Sometimes you might want to start over because I'm looking at this. This is one I haven't done in a while. Let's see. If I put those together, I'm going to get sine squared. Yeah, I see a quicker way I could have done this. Yeah, okay. Let's see. So let's see, that's going to be 2 plus, put these together, it's going to be sine squared of x times the cosine squared of x. And this one's going to be, let's see, I got that one there, so I need a cosine squared on that one. So this one's going to be a cosine to the 4th of x plus the sine to the 4th of x. I want to do that. I'm gonna look at this. Come back to you maybe. It's always good when when the teacher shows you that this can be difficult. Secant squared, let's do it this way. See, this is what I'm saying. There's more than one way of doing it sometimes. Let's do this. Well, that's going to be 1 over cosine squared of x times 1 over sine squared of x. If you put those together, that's going to be 1 over cosine squared of x times the sine squared of x. You ready? Here goes. The 1 is the same thing as sine squared of x plus cosine squared of x, because that's what 1 is, all over cosine squared of x times the sine squared of x. Now break it up. That's going to be sine squared of x over cosine squared of x times the sine squared of x plus cosine squared of x over cosine squared of x times the sine squared of x. The sine squares cancel. That gives me 1 over cosine squared of x plus, and here the cosine squared cancels, and it'd be 1 over the sine squared of x. And 1 over cosine squared is secant squared of x. And plus 1 over sine squared is going to be cosecant squared of x. And since I'm running out of room, I'm going to say that equals the right-hand side. All right. But that one was not the best approach. Probably what I should have done once I got to this point right here is try to put these together, okay? With, putting this as 1 over the tangent squared and put the 1, yeah, that one might have worked that time, okay? So this is the actual proof right there. Sorry about that. I don't care how much practice you have with these and how much you know about this. Sometimes it can come up and get you, okay? And sometimes you just have to start over like I just did. So what I did was I got the product, made them into 1 over cosine squared and 1 over sine squared, put them together, and then realize that 1 is the same thing as the sine squared plus the cosine squared. Then break it up into 2 fractions, make the sine squares go away, leaving me with 1 over cosine squared. Make the cosine squares go away, make it 1 over sine squared, and then change 1 over cosine squared to secant squared, bring the plus down, and there she is. Okay, so, and that can happen to you quite a bit. That can happen very easily. Okay, so it's very easy to get these things jumbled up a little bit, and you may have to start over. That's why I would suggest strongly never, never, never do these in ink. Okay, being perfect, and as I showed you, I'm far from perfect. You're never going to get everything done right the first time sometimes. And so it takes a little bit of work. Okay. All right. So let me get another group. And this is going to be my last little group because I have to go take care of some stuff. And if this is not enough, that's fine. We can go over some on Thursday. But I'm going to just tell you, I mean, if I can do 80, there's 60 of them. I could do 50 of them and leave you the other 10. And that still would not be enough because there's going to be some problems that can throw you. So, all right. All right, here we go. So let's look at number 49. This is another one I really haven't done in a while. Matter of fact, I haven't done a lot of these in a while because I haven't taught this class forever. Cosecant of t plus the cotangent of t. I'm looking at this one. It's almost, to me, better to maybe look at the right-hand side, but let me stay consistent. I'll try with my left-hand side again. So what I want to do this time is I want to multiply the top and bottom by something, because I can't do anything else with this. And so what I want to do is I want to multiply the top and bottom by 1 plus the cosine of t. Now, how doesn't that change the problem? Not really, because 1 plus cosine of t over 1 plus cosine of t is really just 1. So this really doesn't change a thing, but it does help me out a little bit because the denominator becomes 1 minus the cosine squared of t, and then the bottom becomes 1 plus the cosine of t quantity squared. Okay, now the bottom is going to be sine squared of t, and the top is 1 plus the cosine of t quantity squared. But since these are both squared, I can write it this way: 1 plus the cosine of t over the sine of t quantity squared. And then I can break it up and write it as 1 over the sine of t plus cosine of t over the sine of t quantity squared. 1 over the sine of t, remember, is cosecant of t, and cosine over sine is cotangent of t. And there she is. That's the right-hand side. There's a t there. Okay, so that's kind of how we did this one. Okay, it's not, and again, this is not the only way. I saw, and I was tempted to work with the right-hand side first and see if I could get the left-hand side, and it is doable. It was just, I just did it this way instead. So it's not, I don't know which is the most efficient way. Sometimes if you work with the right-hand side, I might could do it in 4 steps instead of 6 here, like 1, 2, 3, 4, yeah, 5. There's 6 steps here. And sometimes you work with it another way. And, nobody's going to be good enough to tell you if you do it this way and without them doing the problem initially, there's nobody can ever guarantee you that their way is going to be minimized number of steps. Okay. And so it may take you 4 steps. It may take me 3 steps. It may take you 7 steps. It may take me 10. It doesn't, there is no one way that's always the best. I mean, there is one way that's always the best. Picking it out just at glance is another story. Okay. So, all right. Now, 53 looks really, really, really ugly. I don't think it's that bad. It looks terrible. Sine of theta minus the cosine of theta divided by the sine of theta. Okay. Plus the cosine of theta. Okay, minus the sine of theta. Okay, and then that's all over the cosine of theta. All right. You got to make sure you write the problem down correctly, because if you don't, then it becomes a lot more complicated because you can't do it. All right. So that's what we've got going on. We have to change that to 2 minus the secant of theta times the cosecant of theta. Okay, how are we going to do that? Well, let's see if we can do this here. Let's see. Let's just break these up into 2 fractions. So it'll be sine of theta over the sine of theta. minus the cosine of theta over the sine of theta plus, now break this one up into two fractions, cosine of theta over cosine of theta minus the sine of theta over the cosine of theta. Okay, now sine of theta over sine of theta, of course, is 1. This one right here is cotangent, so it's going to be, let's go ahead and write as, do I want to do it that way first? No, I do not. I want to leave it that way for right now. Minus the cosine of theta over the sine of theta. This is also 1. And then this one's going to be minus the sine of theta over the cosine of theta. It was tempting to write this as this one as the cotangent and this one as the tangent. You're like, why didn't you? Well, because the right-hand side doesn't have those. See, changing this to cotangent doesn't help. Changing this to tangent doesn't help. But I do know something that can help. 1 plus 1 is 2. And that's that 2 that's on the right-hand side. Minus the cosine of theta over the sine of theta minus the sine of theta over the cosine of theta. Okay. Now over here, I'm going to put them under the same fraction. And the fraction is going to be the sine of theta times the cosine of theta is the common denominator. So that means I need a cosine squared here. And here's the tricky part. That's a plus right there. And then that's the sine squared. You're like, why is that plus not minus anymore? Because the minus that's out front was factored out. I took a minus out of these two terms and brought it out front. So now that becomes plus. Why is that important? Because cosine squared plus sine squared is 1. So, and then you can break that up. 1 over sine of theta times 1 over cosine of theta. And 1 over sine is cosecant of theta. And 1 over cosine is the secant of theta. Now, I know you're looking at that and you're like, wait a minute, you have cosecant times secant. The right-hand side has secant times cosine. That's the same thing. It's just it's the commutative law. So the order that you multiply things don't really matter. So it'd be 2 minus the secant of theta times the cosecant of theta. Okay. All right. So these are the problems that I've done, and I'm not saying I'm going to be done for completely of this thing. I just think I've done enough to get the people who kind of have a clue of how to do this, get them started. Some of you guys, I'm just going to tell you that it's just going to be, sheer terror, because you've got to know your fundamental identities really well. You got to know that cosine over sine is cotangent without thinking. You got to know 1 over sine is the same thing as cosecant without thinking. Okay, so that's the thing. And the thing is, and you're like, well, this does equal that. True, it might be, but even if it's true that one side equals, I mean, you go step 1, step 2, step 3, and you may not have made a mistake from step 2 to step 3. There may not have been a mistake there, but it doesn't help you to get the right-hand side. So, case in point, the problem I did a while ago, I got down to a point that it's not helping me. I made no mistakes, but I could not get the left-hand side equal to the right-hand side. So that told me I took the wrong turn at Albuquerque. But I didn't stress out. I said, fine, this doesn't work this way. You got to be patient. And I started it at a different approach. The new approach worked. So you got to be confident. You got to be patient, and you got to know your fundamental identities. And most importantly, you got to know your algebra. Right here, when I took that negative out, that's algebra. Right here, a lot of people would have thought right there. Let me circle it for you. A lot of you guys probably thought that right there should have been a minus. And it's actually a plus because you take the negative out. You factored it out. And if you put a minus there, then you have no hope of getting 1 down to the step below that. Because 1 cosine squared minus sine squared is not 1. So that's the most important thing is you got to know your algebra. If you don't know the algebra, you can't really do these problems. Okay. So I'm pretty much done with this. I'm going to call it a day here, and I'm just going to let you guys know that sorry I couldn't be with you today, but I will get this one to you, as you'll see when you get this, and this afternoon, and I'll see you Thursday. And if this is not enough, I understand some people like that in-person stuff, and that's fine. And plus, I got a few more problems I need to talk about here that I'm not getting to today anyway. So, but anyway, I'm gonna let you guys go, and hope this will get you started. And hope you guys have a good day. I'll see you on Thursday.